Hey guys, this problem is actually the original problem on the review, and if you're in Mr. Hines' class, you have this question. I actually changed mine. I was trying to get something else to happen, and the problem doesn't work out that way anyway. So never mind. Okay, so I'm going to work this one, and I'm going to work the one that I gave you guys, and then you can have two examples. So if you want to work another one just to have an example, then you can do that. Okay, so when you're working a system of equations, first thing I'm going to do is I'm going to label the equations, okay? So you got the first, second, and third. And the idea is that you want to solve the system for the variables a, b, and c, for which this is true. So you've got three planes, and you want to know when they meet. Okay. Now, in this case, what you want to do is you always want to pick a variable to target. So I'm going to look at all three variables and talk about the pros and cons. A, okay, if I pick A, right away I see that 1 and 3, if I add those two, those will cancel out, which is kind of nice. So then you have to do it twice, so is there another possible? Well, I see positive 1 and negative 3, so if I were to multiply row 1 by a positive 3, they would cancel out. Okay, so I could do that one. That would be pretty easy. Let's talk about B. If I just made one of these negative, then I could cancel those out, and if I multiplied one of these by 2, I could cancel it out with that one. That's another option. And this one, if I made just one of these negative, which you might notice would cancel out that as well. If you notice that, then that actually makes the problem a whole lot easier. But if you don't do that, then you can't. And then, if I was just looking at C, I probably wouldn't choose C because then I'd have to multiply, in order to cancel out a negative 2C with one of these, I'd have to multiply this one by 3 and this one by 2. And while you can do it, it's very easy. It's just more work than the others. So I'm going to pretend like I looked at this and I targeted A, okay? So the first thing I would do is add row 1 and 3. So row 1 is A minus 2B minus 2C equals 3. And row 3 is negative A plus B plus 3C equals 1. Okay? So I'm going to add those two. And if I add them, the A's cancel out, and I'm left with negative 2B plus 1B, and that is B, or negative B. Negative 2C plus 3C is a 1C, and then 3 plus 1 is 4. So I've got B plus C equals 4. Okay. So now what I want to do is I want to target A again, but with two different equations. I can't use 1 and 3. I can use 1 and 2 or 3 and 2, but I can't use 1 and 3. So again, I'm going to go with 1, but I'm going to go with 2. I could go with 2 and 3, but they're both negative, so it's be easier just to multiply row 1 by 3 and add row 2. So I'm going to multiply row 1 by 3. So that is the 3A, a negative 6B, a negative 6C, and a 9. A lot of people forget to multiply that number that you put at the very end as well. You got to multiply by these as well. Don't forget. And then row 2 is a negative 3A plus B plus 3C equals a negative 5. Okay, so I'm going to add these two rows. When I add them, the A's cancel out again, and I'm left with a negative 5B, and then a negative 3C, and then a 4. Okay? So what I do now is I take these two equations that I just ended up with, and I stack them here. Negative B plus C equals 4, and negative 5B minus 3C equals 4. Okay? At this point, I need to do elimination again. And when I think about this, or when I look at this problem, I want to see which one can I cancel out easily. Well, if I multiply the top by a negative 5, that would make it a positive 5 and a negative 5. But it's a little bit easier for me to see just multiplying this C by 3 to cancel out with that one. So I'm going to multiply that row by 3. I'm going to write it right there. So negative 3B plus 3C equals 12. And then just write that one. Negative 5B minus 3C equals 4, and then add them up. So when I add them, I get a negative 8B, those cancel out, and I get 16. I divide by negative 8, and you get negative 2 as your answer for B, okay? Now, if you know B is negative 2, then what you can do is take that and substitute that into either one of these equations, okay? I'm going to substitute it into this one right here. B equals a negative 2, so I've got a negative negative 2, which is 2, plus C equals 4, c equals 2. Subtract the 2 over. So I've got b equals a negative 2, b equals negative 2, c equals positive 2, and I need to find a. So then I take those and I plug them into one of these equations. So I'll go ahead and just use number 1, so a is simple. A minus 2 times b, which is negative 2, minus 2 times c, which is 2, equals 3. So then I've got a plus 4 minus 4 equals 3, a equals 3. Final answer, a, b, c. Okay? But I also want to talk about how to get that with a calculator, okay? If you have a calculator when you're taking the test, then don't forget that you can use matrices. Now, okay, if you're taking the test and it says solve using elimination, then you have to use elimination. But that doesn't mean that you couldn't check your answer using your calculator. So you go to second, and then you go to matrix, which is right above the x to the negative 1 right here. So second matrix. I'll write this order down. So second matrix, go over to the right to math. Okay. Then go up to RREF or down, or alpha B. And then press enter. And you should have this screen, okay? And then you do alpha zoom. So alpha zoom. This is 3 rows by 4 columns, so make sure you're on 3 and then 4. It's okay. And then you want to enter in the numbers. So the numbers are the coefficients, okay? So the coefficient of A is 1, negative 2, and then 3. Negative 3, 1, 3, negative 5. Anyway, you get the idea, so I'll go ahead and type them in. So I got 1, negative 2, negative 2, 3, negative 3, 1, 3, negative 5, negative 1, 1, 3, and 1. Press enter, and I get 3, negative 2, 2, which is what we got as well. Okay? Alright. Now, I'm actually going to work this problem again because I wanted to say, I want to do it in case you did it a different method, because if you notice that B and C on 2 and 3 cancel out, then maybe you worked it that way and you want to know what to do from there, okay? So what if you decided to target B and you just decided to make one of those negative? So 2, let's make row 3 a negative, so minus row 3. Okay, so row 2 is negative 3a plus b plus 3c equals a negative 5. But then you multiply row 3 by a negative, so that becomes a positive a negative b, a negative 3c, and a negative 1. And you add. Well, when you add these, you get negative 3 plus 1, which is a negative 2. The b's cancel out, the c's cancel out, and you're left with negative 6, so a equals a positive 3 divided by negative 2. Okay? If you have a equals 3, then you only need to do one thing. You either need to cancel out a b or a c in one more equation, and then you'll be able to just plug in a equals and solve. Okay? So, what I want to do is I want to target, can't use row 2 and 3 again. So I'm going to target b, and I'm going to target it with 1 and 2. So what I'm thinking is if I take this and I multiply row 2 by 2, so 1 and then 2 times row 2. Okay? So row 1 is a minus 2b minus 2c equals 3. And row 2 times 2 is a negative 6a plus 2b plus 6c equals a negative 10. So multiply by 2. And then I add. So when I add, I've got a negative 5a, b's cancel out, I've got a positive 4c, and then I've got a negative 7. Okay, so what I want to do is then use this right here and substitute in for a to solve for c. So I've got negative 5 times 3, which is negative 15, plus 4c equals a negative 7. I'm going to add 15 to both sides. and I get 4c equals 8, which means c equals 2, which is what we got on the last one as well. We got a equals 3, and we got c equals 2, and then we got b equals negative 2. So again, once you know two variables, all you need to do is take those two, plug them into one of your original equations, and solve for the remaining variable, b, okay? So what I just want to say is, if you work a problem like this and two things cancel out at once, you've got one variable, all you need to do is target one of the other variables, make them cancel out so that you can plug in the variable you do know to solve for one of the others, okay? So at that point, just plug in those two. Okay. Now what I want to do is I want to work the other 36 I have. So if you would like to practice another one, what you could do is just pause this video and if you're in Mr. Hines' class, pause this video and work this problem out to see if you get the right answer, okay? Or you can always work it on your calculator and then make sure you get the right answer. Okay. Row 1, 2, and 3. Okay, I don't think I want to target x's, because if I target x's, then, I mean, it would be fine for row 1 and row 2 if I make one of these negative, they cancel out, but for the 3, I'd have to multiply, and I don't want to do that. If I look at the y's, these two, if I make one of them negative, they'll cancel out, which I don't know if you noticed, but that means that would happen for both of them. So I could do that, and then on this one, if I make these two negative, so the third option, the second one that I would have to multiply on y, is just multiply this row by 2. So to be honest, this is probably the one that I would choose, the y's. So the first thing I would do is I would take row 1, and I would subtract row 3. So row 1 is a negative 2x plus 2. And it doesn't matter which one you put the negative on. You could put the negative on row 1, but I just choose to put it on row 3. So negative 2x plus 2y minus 2z equals 4. And then a negative row 3. So that would mean positive 2x, negative 2y, a negative z, and a positive 2. And then add. So I notice that these two cancel each other out. That one and that one. Leave me with a negative 3z equals 6. Divide by negative 3. I don't know why I wrote that down. Z equals a negative 2. Okay? So like I said, make sure you cancel out something other than the z out, and then you're fine. So I targeted y, so I'm going to keep going with y's. I'm going to pick these two, and I'm going to multiply row 2 by 2. So row 1 plus 2 times row 2. So row 1, negative 2x plus 2y minus 2z equals 4. 2 times row 2, I've got a negative 6x minus 2y plus 2z equals a 2, or sorry, 4. I'm going to multiply by 2. 6, 2, and 4. Okay, add them up, and I get that negative 8x, those cancel out, and I'm left with 8, x equals a negative 1. So in this case, twice something canceled out. You know what I mean? Or two things canceled out. So I didn't even have to use this to find that. I've already got the 2. So in this case, I'm going to take these two and plug them into something else. One of the original. So I'm thinking row 2. So row 2 is negative 3x, so negative 3 times a negative 1 minus y plus z, which is a negative 2, equals 2. So I've got a 4 and a negative 2. 4 minus 2 is 2. So I've got negative y plus 2 equals 2. If I subtract 2 over, I get negative y equals 0, so y equals 0. So what I have is x, y, z. X is negative 1, y is 0, z is negative 2. And let me test that. So second matrix, math, RREF, row reduced echelon form, alpha zoom, 3 by 4, negative 2, 2, negative 2, 4, negative 3, negative 1, 1, 2, negative 2, 2, 1, negative 2. And what did I do wrong? Oh, well, that's silly. And y'all are probably thinking, yeah, duh. Okay, that's a negative 3 times a negative 1, not minus. That's a positive 3. And 3 minus 2 is 1. So, good lord, that's silly. 3 minus y minus 2 equals 2. That is a 1. Negative y plus 1 equals 2. Minus the 1, negative y equals 1. Y equals a negative 1. Oh, well, there you go. So, again, it's a good way to check your answer, because I made a silly mistake. Negative 3 times a negative 1 is, in fact, not 4. It's positive 3. Okay. How would I even get 4? Oh, well. Okay. So, that's working out that one. Like I said, I actually like the other one, following up the one I changed. The fact that you end up with two different ones if you choose a certain variable, it's not always going to work out that way, but sometimes it works out to where you have two different equations that you have to do elimination again with, which is not a big deal. It's just doing elimination one more time, okay? But there you have it. Okay, let me fix that. Okay, then what I want to do is carry on with the rest of the review. So we got 37. Okay. I'll probably get to do 37 and then I'll have to make another video, which is okay. So 37, let's try and target a variable. If I choose the r's, I can make one of these negative, but I got that negative 3, so I probably won't do that. If I choose the s's, I'd have to multiply this by 2 to cancel out with that one, and 3 to cancel out that one, which is not a big deal. We could do that. And on this one, if I just added these two, then they would cancel out, but then I'd have to multiply by those things. So I might as well just choose the s's. So row 1, 2, and 3. I'm going to I'm going to say 1 plus 2 times row 3. So that'll be a 2s, that'll be a negative 2s, and they'll cancel out. So 1 is negative 2r minus 2s plus 2t equals 0. 2 times row 3 is a negative 4r plus 2s minus 6t equals a 2. And I'm left with a negative 6r minus 4t equals 2. And if you notice that all the terms are even, you could definitely divide that 2 out, and it would be a simpler equation. So you could say negative 3r plus or minus 2t equals 1, but that's okay if you don't. Okay, now I'm going to multiply row 3 by 3 and add it with row 2. So row 2 plus 3 times row 3. So row 2 is negative 3r minus 3s plus 3t equals 0. Row 3 times 3, so negative 6r plus 3s minus 9t equals 3. Those cancel out, and I'm left with a negative 9r minus 6t equals 3. Now when I stack these, when I think about the 6 and the 9 and the 4 and the 6, I definitely do want to go ahead and divide these out. I want to divide this by 2. So negative 3r minus 2t equals 1. And I'm going to stack that and that one together. Now, at this point you need to do elimination again. And I don't know if you noticed, but if I were to multiply this top equation by a negative 3, then I would get a positive 9 and I cancel those out. And the same thing you might notice here and there. So let's see what we're left with. I've got a positive 9r plus 6t equals a negative 3. I've got a negative 9r minus 6t equals positive 3. I get 0 plus 0 equals 0. Now, if you got 0 plus 0 equals like 15, that's a false statement, no solution. But I got 0 plus 0 equals 0, which is a true statement, which means infinite solutions. Okay? When you get a true statement, that means infinite solutions. If you get a false statement, that means no solutions. Okay. And that is going to be those two problems. gonna have to make another one because the bell's about to ring. Okay.